Hey, how are you guys doing? Another day, more logarithms, right? I know you missed it, right? Couldn't wait, couldn't get yourself to sleep last night because you were dreaming of all those properties of logarithms expanding and what we're going to talk about today, condensing, all that great fun. All right, so the good news about today is we're really going to just reuse those same properties that we talked about in the last lesson, but now we're going to reverse the process. So instead of expanding, we're going to condense. All right, so to kind of just jog your memory a little bit, we have a couple of warm-up problems, 1A, 1B right there at the top of our note sheet, which are expanding our logarithms, all right? So what I would love for you to do is give 1A and 1B a shot, pause the video, come back on, check your work, and we'll see what you remember. All right, so gave you some good work here, all right? So let's see if you picked up on some of the subtle details here. So when we talk about 1A, all right, the arching operation that we have to take care of first, the major operation is that quotient. All right, so I'm going to take my numerator here, so log base 5 of y to the 8th times y minus 1 to the 4th minus log base 5 of the denominator, which is y squared minus 9y plus 20. Now, when I look at each piece, when I look at this, now, all right, the major operator within the argument here is multiplication. So now I'm going to use my product rule. All right, I'm going to break that apart to log base 5 of y to the 8th plus log base 5 of y minus 1 to the 4th. Now, oh, this is where I wondered if some of you would pick this up. All right, that's right. You have to F this up. You have to factor this up. All right, so hopefully on the side, all right, you factored y squared minus 9y plus 20 into y minus 4 and y minus 5. All right, now we have to go back and reevaluate. Now, what's my major property, major rule? What can I do here? All right, and that's that power rule. So now I can take the 8 and move it out front as a product. Same thing with our second part. I can now take this 4 and move it out front as a product. And then now when I get to this piece, the major rule is the product here. I have y minus 4 times y minus 5. So I can break that into two pieces. Now, remember, because those two pieces are behind the negative sign, they are both going to be negative. So I'm going to have minus log base 5 of y minus 4 minus log base 5. All right, lost my 5 somewhere in there. See if I can squeeze that in. 5. There we go. Maybe. Log base 5 of y minus 5. Okay, now moving on to 1b. We have the natural log here. Now, the major operator here is that we have the entire argument raised to a power. All right, so to get to the internal pieces here, we have to take care of this 5 first. So we're going to move that 5 out front, and we get 5 natural log of x to the 5th plus x to the 4th plus 18x cubed. And guess what? That's right. Gotta factor it some more. Now, in this case, it's a two-part factoring problem. So the first part is that we have to factor out a GCF of x cubed. All right, so I factor out that x cubed, and that gives me x squared plus 11x plus 18. Now, once I get to that, now I can factor the quadratic into x plus 9 and x plus 2. And so what I see is I now have, all right, a product of three things in my argument. So now I can use that product property. Once again, I'm going to leave that 5 out front. I'm going to have the natural log of x cubed plus the natural log of x plus 9 plus the natural log of x plus 2. Now, as I go back and reevaluate each piece, I'm going to leave that 5 out front, and I have one more property I can apply to this, which is that power property. I can take that 3 and move it out front. Now, the next two parts, there's nothing else we can simplify, nothing else we can do to that, so we just leave it like that. And then once again, if you want, you can distribute that 5 to everything inside our parentheses here, or you can just leave it sitting out front. Either way is fine. All right, so hopefully that triggered your memory of some of the things that we talked about last time. And like I said, now what we're going to do is we're going to start with this, and we're going to try to go back to this, right? We're going to start with this and work backwards to this. All right, so we're going to just reverse the process. So now let's go back and look at our note sheet here. And just as a reference for you, all right, that's not what I wanted to do. So let's go back and, whoa, what is going on here? All right, come on, you can do this, you can do it. All right, hold on a sec. Let me see if I can fix this. All right, and I'm back. Okay, I think I've got it all. It's still not working real well here, but We'll see how we can progress here. But so just as a reminder from last time, here are three major rules of logarithms, properties of logarithms. We have the product rule, so log base b of m times n, we can rewrite as log base b of m plus log base b of n. Now, what we're going to do today is we're going to see the right side, and we're going to try to make it look like the left side. So same thing here with our quotient rule. Log base b of m divided by n is equal to log base b of m minus log base b of n. And once again, we're going to start with the right side, and we're going to condense it to make it look like the left. And then finally, our power property, right? So if we have log base b of m raised to the power of a, right, that a can be out front. And so we're going to kind of move in reverse here. And so just some general guidelines as we condense is that typically you want to take care of the power property first, right? So if we have that a, typically what we want to do is move that in, all right, move that a value in, and then we can start doing our product or quotient properties and condensing that way. All right, so now let's look at log base 4 of 2 plus log base 4 of 8. All right, so now when I look at this, all right, we can see that there's no a values to take care of, but I have the addition here. So I'm really in this first rule right here. So what I can do then is create a product here. So let me see, let's start with blue today. All right, so go up here to blue. And so I can rewrite this now as log base 4. All right, log base 4. And then I can do my product, which is 2 times 8. Now, 2 times 8 is 16. Now, just like we talked about before, all right, that what we want to do is look at this and see if I can simplify, right? So log base 4 of 16 can be simplified, and I can just rewrite that as 2. And you can see that my system is really dragging this morning. All right, so that's a 2. Kind of a quirky looking 2, but it is a 2. All right, so now let's move on to number 3 here. All right, so once again, we don't see an a value here, so I'm good here. But, all right, I do see an a value here, so I want to take care of this before I get to the subtraction here. So I'm going to have the natural log of 4x minus 3 and I'm going to now use that power property, and I'm going to take that 2 and make it the power of x here. So natural log of x squared. Okay, now once I've done that, now what I see is I'm subtracting 2 logs, right? And that means we're now going to use property of our quotient rule. So now I'm going to rewrite this as a quotient. So natural log, and then this is going to be my numerator. So 4x minus 3 is my numerator. And that would be over x squared. Okay? And that is our quotient. Now, what you can leave it like that. Sometimes I'll do this, sometimes you'll see it, but if you want, you can just put the whole thing, all right, in parentheses if you would like, but you don't have to. All right, so there you go. All right, so now let's look at one more together before I let you do a few. All right, so once again, let's look at number 4 together. All right, now once again, as I look, I see I have one a value here. So I want to take care of that first before I start condensing, all right, with my product property. So I'm going to have log of x squared of x squared. And I'm just going to bring down the rest of the problem here, all right, because there's nothing to simplify on those right now. All right, so I'm going to bring those down. All right, so like I said, I'm just going to bring those down. Now, what I see is that everything is being added, right? So if everything is being added, all right, we're really in the same property here, all right, and we just want to multiply all those arguments together. So I'm going to have, I have 3 logarithms that are being added, so that means I'm going to have 3 things being multiplied in my argument. Now, you do not have to expand these when you bring them in. We can just write them as a product. So log, right? And so we can just have x squared and then times x minus 2 and then times x plus 2. and we can leave it like that, all right? If you want to expand it, you can, all right? You can multiply all that out, but it doesn't really help you in many ways, so you can just leave it as a product like that. Okay, so here's what I would like you to do is I would like you now to pause the video, and I would like you to try 5, 6, and 7 and see how you do. And then once again, you can turn the video back on and check your work, or you can print off or open up the Fully Worked Notes key online to check your work. All right, so I have these 3 worked. So I'm going to flip over here, which is great because my system is like super slow right now. And once again, we want to take care of that power property first. So now, once again, remember, the 1/2 power is really the square root. So when I take that back in, that's going to become the square root of x plus 2. I'm going to take this 4 and place it back in. That's going to be x minus 1 to the 4th power. I'm going to take that 3 and push it back in, and that's going to be x to the 3rd. Now, once again, and just like in example 4, we can see that I'm adding all 3 logarithms, right? So that means I can just have a product of all 3 arguments here. So log base 5 of square root of x plus 2 times x minus 1 to the 4th times x to the 3rd. Now, once again, the order within this does not matter. All right, so some people might move the x to the 3rd in the front or whatever. It doesn't matter as long as you have all 3 pieces and they are being multiplied. Now, with number 6, there's a couple different ways to go about the problem. The first way is to do what I did, which is you could just go ahead and distribute this 1/3, all right, to both terms, which is what I did. And now I can move that 1/3 in as a power, all right, like I did. Now remember, 1/3 is the cube root, so when I move that in, that's the cube root of x, and when I move that in, that's the cube root of y. Now notice, now we have a subtraction, so now we're in the quotient rule, which means I'd have log base 2 of the cube root of x divided by the cube root of y. Now, technically that is correct, but probably what you would see if this were a multiple choice question on a standardized test, or if you're checking your answers in the back of a textbook, right, is that if both the numerator and the denominator are taken, or if you're taking the cube root of both the numerator and the denominator, you're probably going to see that cube root moved outside, and it's just x minus y. Now, you could get to this the same way if you simplified in the parentheses first, because notice this is a subtraction problem, right? So I could do log base 2 of x divided by y, and then I can take that power inside, and that would give me the same result. Okay, so let's check out number 7 here. And once again, that 1/2 power becomes the square root of x plus 1. 2 becomes x squared, and there's nothing to do here. And then this 2 comes back up and becomes x minus 9 squared. Now, if I look, these 3 things are being multiplied. All right, they all are positive. So now this piece is much like what we just did right here. So I'm going to rewrite this, and notice I did rearrange the order here. So I did 4 times x squared times x square root of x plus 1, just to make it look a little better inside of this. Nothing else to simplify right here. But now that I've combined all these, notice now my next property here is a subtraction, which means we're in the quotient rule, right? So all of this guy would be my numerator, and then this term would be my denominator. And like I said, if you wanted to multiply x minus 9 squared out, you can. No need to. Doesn't really help you. All right, so we have a couple more problems left for today. I'm going to do one more with you, all right, because I just want to focus on one particular thing to make sure you're aware of it, and then I'm going to have you do number 9 on your own. So let's go through number 8 here. Now, the one thing that I want to mention, all right, is this idea of terms being positive and negative, right? So basically what we know is every term that's being positive is going to be multiplied together, right? Every term that's negative would also be multiplied together, and eventually we're going to end up with a quotient because of that negative, and those terms will all end up in the denominator. So what I'm going to do as I go through this problem is I'm going to rearrange my terms so that all my positive terms are first, and then all my negative terms are at the end. That way, as I group and kind of organize things, it'll make it easier to see which properties to use. All right, so I'm going to go ahead and I'm going to do my power property here. And so what I'd like you to do, all right, is I'm going to pause this because I'm running really slow, and I'm going to rewrite this really quickly and then jump back on. Okay, so let me talk about what I just did here. So I did the 3, moved that up here, that's x cubed. I took the 1/2 and placed it back in, and that's the square root of y. Now notice, this term is negative. So what I did was I just skipped it for a second because I want to make sure I get all of my positive terms first. And so then I did this, 5 to the y plus 1. And now I have all my negative terms at the end. So minus log, and then I'm going to put the 2 up, x minus 2 squared, minus, and then I took the 3 up log of z cubed. Now, here's why I want to do this, because these 3 terms are all positive. So now I'm going to use the product property on these 3 guys. So I would have log, all right, and I'd have x cubed times square root of y times y plus 1 to the 5th power. And that would be all one product. Now, technically, right, these are both negatives. So I'm going to take the negative out of both of those terms. All right, and by doing so, really what happens is it looks like this now. All right, and so now by taking that negative out, notice now I have a positive term here. So this is going to be a product rule as well. And so that becomes log of x minus 2 squared times z cubed. All right, and that's why I wanted those negatives together, because then I can factor that negative out of all those terms, and I can use the product rule on those. And now what that sets me up for is now I have this negative here, which means it's really a quotient rule problem. And so now when I set this up, I know I'm going to have a quotient. All of this is going to be my numerator, so x cubed times the square root of y times y plus 1 to the 5th. All right, divided by x minus 2 squared, and then z cubed. And that's my final answer. All right, Winter's excited about it. She couldn't believe that it worked out to be like that. All right, so we wanted to give her confirmation in there as well. All right, so here's how I'd like to wrap up today's lesson. Is I would like you to try number 9. All right, and simplify that, condense that that problem, and turn the video back on. Let's see how you do, or check your notes with the Fully Worked Notes online. All right, so this was a little simpler than number 8 in the fact that, right, all my positive terms were first, all my negative terms were second. And so once again, taking that power rule and putting it back in on the first term gives us log base b of x squared, but none of the other terms, right, had a power. Now what I decided to do because of that is, just like I did in number 8, I factored the negative out of these 2 terms. All right, and that gave me log base b of x minus 6 plus log base b of x minus 1. Now I can use the product property on these 3 terms. So I get log base b of x squared times x minus 5 times x plus 5, or x minus 4 times x plus 5. And then I can use my product property on these 2 terms. So I get log base b of x minus 6 times x minus 1. And then in much the same fashion as our prior problem, now this makes it one big quotient problem. All right, so all of this becomes my numerator. All of this is now my denominator. And so I have fully condensed that logarithm. All right, my friends, that is the end of our lesson on logarithms. All right, so it's time for you to go practice. So look up the homework online. All right, you got the answer keys to help you. All right, you can email us, contact us, come to our Google Hangout or Zoom session, our office hours, whatever you might need. Let us know what we can do to help you. All right, hope you guys are taking care of yourselves. All right, have a wonderful day, and I will see you next time.